Hey there, data enthusiasts! Welcome back to our channel, where we dive deep into the world of data science and machine learning. If you're passionate about understanding how to make better predictions and models, you're in the right place. Today, we're going to tackle a really important concept, model regularization. So, grab your favorite drink, sit back, and let's get started. But before we dive in, let me ask you this. Have you ever trained a machine learning model that performed exceptionally well on your training data but completely flopped on your test data? If so, you might have encountered the issue of overfitting. This is where model regularization comes into play. Alright, so what exactly is model regularization? In simple terms, regularization is a technique used to prevent overfitting in machine learning models. Overfitting occurs when a model learns not just the underlying patterns in the training data, but also the noise. This means that while the model performs excellently on the data it was trained on, it struggles to generalize to new, unseen data. Imagine you're trying to teach a friend how to ride a bike. If you only let them practice on a smooth, straight path, they might not learn how to handle bumps, turns, or rough terrains. Similarly, a model that overfits becomes too specialized to the training data, losing the ability to perform well in real-world scenarios. Now, let's explore some common techniques of regularization. First, L1 regularization, also known as lasso regression. This technique adds a penalty equal to the absolute value of the magnitude of coefficients. The effect? It can drive some coefficients to zero, effectively selecting a simpler model. Suppose we're predicting housing prices based on various factors like size, location, and number of rooms. If some features don't significantly contribute to the price, L1 regularization can eliminate them, leading to a more interpretable and efficient model. For example, let's say we have a dataset with 100 features. After applying L1 regularization, we might find that only 10 features are essential for predicting housing prices. This not only reduces the complexity of our model but also improves its performance on new data. Next, L2 regularization, or ridge regression. Unlike L1, L2 regularization adds a penalty equal to the square of the magnitude of coefficients. This means that while it doesn't eliminate features entirely, it does shrink their coefficients. It's like putting a soft constraint on the model's complexity. To illustrate, imagine you have a model with a high number of features. By applying L2 regularization, even if all features are retained, their influence on the predictions is moderated. This can lead to a more balanced model that is less sensitive to fluctuations in the training data. Finally, elastic net regularization. This is a combination of both L1 and L2 regularization. Elastic net is particularly useful when you have many correlated features. It allows for variable selection and coefficient shrinkage simultaneously. Picture a scenario where you have multiple factors influencing a car's price, such as engine size, fuel type, and brand. Some of these factors might be correlated. Elastic net will help you keep the relevant features while mitigating the effects of multicollinearity. Now, you might be wondering how we can determine the right amount of regularization to apply. This is where techniques like cross-validation come in handy. Cross-validation involves splitting your dataset into multiple parts, training the model on some parts, and validating it on others. By adjusting the regularization parameter and observing performance metrics like accuracy or mean squared error, you can find the sweet spot for your model. To summarize, model regularization is a vital technique that helps prevent overfitting by adding constraints to your model. By employing methods like L1, L2, or elastic net regularization, you can enhance your model's predictive ability and ensure it generalizes well to new data. Remember, a simpler model is often more powerful, especially when it comes to real-world applications. Thanks for joining me today as we explored the fascinating world of model regularization. Remember, whether you're a seasoned data scientist or just starting, understanding how to manage model complexity is crucial for building robust and reliable machine learning models. If you found this video helpful, don't forget to give it a thumbs up, subscribe to our channel for more educational content, and hit that notification bell so you never miss an update. And as always, if you have any questions or topics you'd like us to cover next, drop them in the comments below. Keep learning, keep experimenting, and I'll see you in the next video.